Solving a quadratic equation in x by completing the square. So you got to divide both sides by the equation by the coefficient of x squared. Yeah, because we really just want it to be phantom 1x squared. We don't want a coefficient with x squared. Then you isolate all the variable terms on one side of the equation, which means we don't want any constants on the same side. So we complete the square of the resulting binomial by adding the square of half of the coefficient of x to both sides of the equation. Now that doesn't have to make sense, which it probably doesn't, but it's this. You need to remember here that it says you're adding the square, so that would be a power of 2 of half the coefficient of x, not x squared. Okay, so I'm gonna be a math nerd here, which I always am, but that's ax squared plus bx, and it should equal some value over here, some number. You could put c if you want. Okay, but the middle coefficient is the term we refer to as b. What am I doing? B better. That's okay. Okay, so you're going to take b. It said half of that coefficient, so you're going to have to divide that by 2. But you're squaring that. Okay, now this is something that you're adding. This is a constant, by the way. I did not put the x in with that term that I'm squaring. But that's what you add. That is what ends up being added. This stuff right here. That ends up being added here. But remember, that I kind of arbitrarily put that there. So if you do it to one side, you'd have to do it to the other side as well. So you'd have to, okay, well, I added it here, so I'm going to have to add it there as well. Now, once you get that, because you've done this, you've taken b divided by 2 and squared it, then it automatically will become a perfect square trinomial. That's why it's called completing the square, which means that whatever this b over 2 is, this part right here ends up just being, well, the a is 1, by the way, but it ends up being a perfect square trinomial, meaning you'd have x, and then I guess it'd be plus or minus, but whatever b over 2 is. And then it equals whatever you have on the other side, which you can just put into a calculator. I know this probably isn't making a ton of sense right now. Hopefully example will, but you factor the resulting perfect square trinomial and write it as a square of a binomial. Again, this should be a perfect square trinomial. Use the square root property to solve. Because once I get this squared, then I can square root both sides. I get my 2 answers, and then I feel so good. So by completing the square of the expression, find a and b. So I'm showing it right here like this. On the assignment, they actually may show it like this. So I'm going to show it both ways. Okay, so sometimes they want to know what's being added. Yeah. This one is taking this expression and then changing it into a new expression. But I'm going to take the expression and change it into an equation instead. I'm going to do both. So let's ignore that first one for now. So I'm going to erase it so it's just out of sight, out of mind. Let's just focus on this first one. Okay. So so this one's great because the coefficient of x squared, it's already a phantom 1. That's very generous. But what I'm going to do is I'm going to take my x squared plus 10x, and I'm going to purposely offset my plus 24, because 24, like if you tried to factor, oh crap. Well, if you tried to factor 24, you could use 6 and 4 there, and then make that a factored trinomial. But it's not a perfect square trinomial. That's what we got to do with these completing the square business, okay? So that's not what we want. Again, you could factor that out if it said, hey, please just factor it, but it says complete the square. So I'm offsetting the 24. Now, in order to figure out what goes here, it will also affect what I'm going to have to do to the 24. Okay, now that, again, it may not make a lot of sense right now, but really all I'm focused on right now is these 3 terms in order to force a trinomial that is a perfect square trinomial. Well, how do you do that? You're going to take the 10, the middle coefficient, which is 10. You're going to divide it by 2, and then you're going to square it. Okay, now I'm going to operate here. I know 10 divided by 2 is 5, so I can square that. 5 squared is 25. So if I were to take that x squared plus 10x, and let's say I added 25 to it, then these 3 terms, these 3 are now a perfect square trinomial. But I can't just add 25. It's not an equation. So really what I'm going to do is add 0, but I've already added 25. So how do I make that 0? Minus 25. Okay, so I didn't change the equation by just saying I'm going to add 25 and then I can sing and dance. I gotta make sure I balance that out by also taking away 25 from both parts of this equation, right? Because I've got the trinomial and then I'm dealing with just the constants as well. Yeah, so right, it doesn't look like we need this stuff, but once we start seeing equations, then we're gonna need this stuff. Yeah, I guess kind of. So this guess I should have given myself more space. But the 25, right? So I can say, all right, my 25 right there. 5 plus 5 is 10, so that would then be x plus 5. I'm not going to do it twice. I'm just going to show a power of 2. And then over here, I've got 24 minus 25, which would be negative 1. And so the way they have it up there, right, they're saying, well, x plus a squared plus b. Right here, I can see that the a is 5, and then the b is negative 1. Okay, now that's this format. If they give you this format, this is your a and b. Like I said, they may change the format.
Where did you get the negative 1?
So how does that change? Well, the expression right now that we have, we're showing is x plus 5 squared. And we had it as minus 1. So really we would just say, look, make this equal to 0. And then to solve that, you would just add 1 to both sides. If that zeroes that out, then you get 1 equals the x plus 5 squared. And the format, like I was saying, is that x plus a squared equals b. So in this scenario, a still equals 5, but now the b is a positive 1. So I'm showing both formats because I can't guarantee which one they're going to do. Like I said, I think it's usually going to be this one. So I'm going to box this one in. But again, this format, these two can still work depending on which one it asks for. Now, here's the thing is, the way that we explained this process is usually you would take this constant 24 and then move it to the other side of the equal sign. Now, if this equals 0, you'd end up with negative 24 over here. So if you added 25 to one side, you can balance that out by simply adding 25 to both sides if it were an equation. But this one was an expression, so I was forced to make it a 0 by adding 25 and taking away 25.
So the